Okay guys, so we are going to discuss continuous uniform distribution. Now what does continuous mean? Continuous means that there are infinite number of outcomes, and since there are infinite number of outcomes, you can't count the number of outcomes. The next term is uniform. Uniform means that each outcome is equally likely. The probability of each outcome is going to be the same. So what could be the example of a continuous uniform distribution? Right. The example could be a random number generator where probability of getting any possible outcome is same. Probability of getting any possible number is same. So let's understand this in Excel. So let's go to Excel. Okay. So notice here I have used a rand function. Right. I'm using this rand function to generate random numbers between 10 and 20. So I've used RAND function which generates random numbers between 0 and 1. I have multiplied it with 10 and I have added 10, right? And this function is going to generate random numbers between 10 and 20, right? Notice these numbers run in several decimal places, and since they run in several decimal places, uh, the number of outcomes are going to be infinite, right? So since the number of outcomes are going to be infinite, we will say that this distribution is continuous, right? Second thing is that I'm using the rand function to generate these numbers, right? So since I'm using a random number generator, the Excel in the background is is generating numbers randomly. So the chance of getting any number is going to be the same, right? And since the chance of getting any number is going to be the same, this distribution is also going to be uniform, right? So this distribution is both continuous and it's going to be both uniform, right? Now we know that in a continuous distribution, we measure probability within a range. We can't measure the probability of a specified outcome, right? So we can't measure the probability of getting 11.56889, right? This does not mean that getting this number is an impossible event. It's very much possible. Getting this individual number of 11.56889, it's not an impossible event. It's very much possible. But the problem is that it's very hard to measure the probability of getting this number. And since it's very hard, we assign it a probability of 0, right? So we can't measure the probability of a very specific outcome in a continuous distribution. So what we do is we measure probability within a range, right? So let's create a range. Okay. So say, with the upper bound of this range is 20, lower bound is 10, because by using this rand function I am generating random numbers between 10 and 20, right? So let's create 10 intervals with a width of 1. So I'm going to have such 10 intervals. So I have 10 intervals between the upper bound and the lower bound, and the width of each interval is 1. So since this distribution is uniform, these equal sized intervals would occur with the same probability. Now what does this mean? This basically means that probability of getting a number between 10 and 11 shall equal the probability of getting a number between 11 and 12, which shall equal the probability of getting a number between 12 and 13, and so on and so forth. So now we need to know what is the probability of getting a number in any individual interval. How are we going to calculate that? Okay, so see, there are 10 intervals. So total intervals are 10, and the total area, we know that under any probability distribution total area is going to be 100%, right? Why? Because we know that the sum of all possible outcomes in any probability distribution adds up to 1. Sum of all mutually exclusive and exhaustive events add up to 1. So the total area under this distribution is going to be 100%, and the total number of intervals are going to be 10. And we know that equal sized intervals would occur with the same probability, right? Okay. So the probability that we can assign to each of these intervals is 100 by 10, that is 10%. So this basically means that there is a 10% chance of getting a number uh, between 10 and 11. There's a 10% chance of getting a number within 11 and 12. 10% chance of getting a number between 12 and 13, so on and so forth, right? So this is my continuous uniform distribution, right? So guys, hope you've enjoyed this. Hope the idea is clear.